dv by dt. This further dv, what we can write it as, further this dv into dt. No. This, let me go for integration. U, v at t equals 0, initial velocity is u. At any time t, let v be the velocity. Then the equation will become v minus u. So what is this A dt? This should be the area. And what is LHS? LHS is change in velocity. This is area under 18 graphs. So from acceleration versus time graph, the area under 80 graph will give us the change in velocity. Means if I have a curve, then how the area, so this is what everything will become area, no? So this is the acceleration time. What is that dt? The dt is this one. So if you can ADT is the area of the strip. No, such strips, if you add up, you'll get the area under the curve. Such strips area, if you add up, what do we get? We get area under the curve. So therefore, total area in the curve, and what is equal to change in velocity. I think this will be a very, very important formula for us. It's going to really help us a lot in working numericals. So here, of course, what do we remember? Area under VT graph is equal to change in velocity. I have brought a problem now. Let's work out this numerical. I have a numerical here. The acceleration versus time graph of a body, which is where the body is at rest at t equals 0, is as shown. Look at the acceleration. It increases from 0 to 2 seconds. Then acceleration constant. Then acceleration decreases. Some very fundamental, very, very, very important. Very simple, and at the same time, it's very important. Okay, now first, look at this acceleration, 0 to 2 seconds. We'll define this. I'm writing directly, a equal to 2t. For 0 to 2 seconds, what is the equation for acceleration? It is equal to 2t. What is the slope of this? 4 by 2, 2. Equation of straight line passing through origin. Instead of y, you are having a. Instead of x, you are having t. Then afterwards, uniform accelerated motion. So acceleration remains constant for next 2 to 4 seconds. Then look at this, having a negative slope. This having a negative slope. Then what is the slope of this? Will be -4. And the intercept will be +20. If you extend this curve, it will intersect the y-axis at +20. This curve will intersect the y-axis at +20. Agreed. That's the basic condition. Okay, now after this, what we do is like, Master, why you are doing all this? See, we have to study the motion here, no? Like we have to analyze the motion here. So what is this? Acceleration increasing. Acceleration constant. Acceleration decreases. So we do call this a retardation. The answer is no. There's also an accelerated motion. How come? I'll take help of this one. So first we'll calculate what do the areas indicate. Four. What do this will be? Now what I'm doing, I'm calculating area. This is A02, area under the curve for 2 to 4 seconds. 4 minus 2 into 4. So this will be 8. Area under the curve for 4 to 5. Half into 5 minus 4 into 8. 2. Okay, these are the areas. Let's calculate area under the AT graph is what changed in velocity. Initially it was at rest. So we'll calculate here now. What is V2? V2 minus V0 should be equal to A02. See, we need data. We can't just accept blindly all these things. I'm bringing the data here. What is the speed of object at 2 seconds? 4 meters per second. Then again, we'll go for this. This will be V4 minus V2 equal to A42. A42, what is A42? It's plus 8. So V4 equal to 12 meters per second. Speed of the object at t equal to 4 seconds. This is then V5 minus V4 equal to A45. What is A45? 2. V45 is 12. V5 is equal to how much? 14 meters per second. Everyone, I want you to look at this values. What do you mean by acceleration? If speed increases, it is said to be acceleration. We are not bothered about acceleration increasing or decreasing. Speed of object increases, it is said to be acceleration. That's all. So acceleration increases. Is it accelerated motion? Acceleration decreases, retarding motion? No. Speed increases, acceleration. If a speed of body increases, it is said to be accelerating. If speed of body decreases, it is said to be undergoing retardation. That's all. Look at now. It was at rest. 2 seconds, it will move. Okay, speed is increasing. Speed is increasing. Then again, next again, like for 2 to 4 seconds, speed is increasing. No, from it was 4 meters here, now it is 12. So speed is increasing. It's an accelerated motion, but uniform accelerated motion. Then for 4 to 5 seconds, the speed of object is increasing, but acceleration decreasing. So it's again, you have to call this as accelerated motion only. Acceleration increases, speed increases. Acceleration constant, speed increases. Acceleration decreases, speed increases, but you have to call this accelerated motion only. Acceleration decreases means not retardation. Speed decreases should be retardation. Speed increases. So therefore, I should call this as still accelerated motion only. This is. It is an accelerated motion only. I am repeating several times because this is something very important for us when we go for laws of motion chapter. Okay, so we are able to calculate the all the quantities here. Now then, can we do this mathematically? As you are interested, you can go for maths. Already we have discussed in the so mathematical treatment will do it. A is equal to math. Graphically, this is mathematically. For t, let me derive this. So if you solve it, we'll end up this as 4 meters per second. Then again, uniform accelerated motion, V4 equal to V2 plus A plus the time 4 minus 2. Solve it. What about the retardation? What is the equation? The equation will be A equal to, I have place here, I'll scribble it. This is for interval of time. and next for t less than 5 seconds to 4 seconds. So what is the equation? Minus 4t plus 20. So now we'll solve this. dv is equal to, you can solve mathematically if you are very good in calculus, or else you can take help of graph. So what was the limit? It was 4, velocity is v4. Then this will be 4 at t equal to 5 seconds, calculate the velocity 5. Solve it, you'll end up with 14 meters per second. On one side, calculus. The other side is what? Graphical method I'm showing. So all the information you can extract from these graphs here. How the VT graph, because you see this, the equation for V as a function of time. If you're trying to plot V as a function of time, we'll get it. So how do you can plot the graph? Okay, this you do one thing. This instead of you write it here, V. Then substitute 2 limit. You'll get one. So look at the V equal to t square parabola. Okay, therefore the curve is parabola. You know there's a uniform retarding motion. I need to explain much. Then sir, how come you plot this curve? So you have this. Instead of substituting upper limit, just leave as t. V4 is 12 V t. Solving this, we'll get expression for this as V equal to 12 minus 2t square plus 20t. When you plot this, the curve will be this one. If you are plotting curve, you need equation. Then you should not substitute the upper limit. These limits, write t, then you'll get V as a function. Then this would be curve. Little bit, you need equations to predict that curve. No, position versus time graph, accelerated motion, accelerated motion, accelerated motion.